Well, right, there we go. We are recording. Oh, there's Maik joining as well now. So yeah, we'll kick off anyway. So good evening, good afternoon, good morning, good night, whatever you are. There's quite a mix of people on the call. I know it's quite a global thing we got today. So look, thank you everybody for joining. Welcome to the Welsh Azure user group on the 19th of March. Good to see a couple of familiar faces coming through the door. No doubt we'll have a few more if the numbers stack up. So let's jump into it then. Just in terms of timing, that's what we're looking at. I'll just do my usual preamble. Got a little bit of a news section to take you through as well tonight, just something a little bit different. Before we kick off with Turja, who will be joining in about 10-15 minutes or so to take us through designing multi-tenant architectures in Azure. Going to talk us through some of the approaches, best practices, and obviously, the main points, which are the gotchas. They're the learnings there, right there. So yeah, quite interested personally on that one. I've been speaking about that quite a lot actually. So really keen to see what you got there, Turja. Looking forward to that talk. And then we've got Maik van de Gaag joining then for the second talk around roughly 7:30ish, something like that. Empowering your organization with reusable Bicep modules and automatic deployment. So yeah, really, great talks around that infrastructure as code and always worth kind of, if you do a lot, having a revisit. If you've done nothing, getting a little bit educated. There's always some good learnings to be done. And as always, our quiz. So stick around after Maik's talk, about 8:15 UK time, that is, I should say. We've got the quiz, and there are prizes to be won. So stick around for that. So yeah, look, roughly looking about 2 hours or so, we should be done for the event. But obviously, take part and be interactive. But to start things off, then, big hello from myself and Mr. Matt Fatonka. We are the last standing guard, I guess. We started with 5 or 6 folks organising these user groups, and I think because we stuck virtually, there's it's good to organise, but let's face it, it's not as hard pressed as a face to face, which we keep threatening we're going to do, and we're going to go back. In fact, we're in talks at the minute about
There's
doing a bit of
conversations happening.
there's
Yeah.
conversations happening. It's a bit of an anniversary for the user group this year. We'll be turning 5 years old, and obviously we've had great support from the community and speakers as well. So we might try and push the boat out and do something different. So look, if there's any questions, thoughts, ideas, you want to take part, you want to speak, you want to whatever it might be, reach out to me or Matt. There's our LinkedIn addresses there on the screen. Happy to hear from you. Next up, bit of housekeeping as always. Should go without saying, but obviously, please, everybody, please do be courteous to each other. We're all here to learn and have an interactive, enjoyable evening if we can. Of course, there are no silly questions. This is the whole point. We're here to learn. We're here to support the speakers, and it's an opportunity to ask those what you may deem a silly question. Get them in the chat. Nobody will be judging you. It's a safe space. Just get it in there because at the end of the day, everybody's probably thinking the same, right? We will all probably learn from it. But please do stay on mute unless you're invited to speak and come off mute by one of the speakers. Obviously, it goes without saying just to keep the noise down to a minimum because it can be off-putting. Like I say, please feel free to drop any chats or comments in the window. Be interactive, help each other out. Normally, everybody will answer each other's questions and have a little bit of fun. It's normally a bit of a meme war going on or something like that. And like I say, after our second speaker tonight, we've got the quiz and we've got some Amazon gift vouchers to give away. But most importantly, be interactive and enjoy the session. So, just a quick meet the speakers, just to refresh. They're the two talks with Turja and Maik that we are going to be uh, going through this evening. Once I get through my little preamble, a slight new addition to today's preamble. I thought I'd pick out a little bit of Azure news, being that what caught my eye really was obviously we've got NVIDIA GTC conference going on at the moment, which, always impacts positively, the offerings and things going on the Azure platform. So, of course, just to kick into this section about, and I won't take long, it's really just meant to be 4 or 5 things that have caught, Matt's eye over the last kind of month, just to kind of pick out and, bit of food for thought, a few links to click on. But the first one, whether or not you caught the announcements, but we've got serverless GPUs for Azure Container Apps with NVIDIA NIM. So NIM is NVIDIA Interface Microservices. That's gone GA after the announcements at NVIDIA, which basically means that we can run containerized AI models within, a serverless GPU Azure Container App, essentially, which really democratizes the use, configure and query these models via API endpoints. And I thought it was quite a groundbreaking thing. And literally just before we kind of kicked off, me and Matt, we were talking about NVIDIA and just, the whole world of what you can learn and how you can get into, and the kind of different levels of offerings that they got is really, really encouraging and exciting to see. So, I urge you, go and have a click on that and have a look in Azure AI Foundry, because the model catalog, I'm hoping, should be updated by now, and you can probably start to have a little play with these as they've literally just gone GA over the last 24 hours. So that was the first bit of news. Then I got a few other little bits and pieces that might tickle your fancy, so to speak. So Azure Firewall update, if you're an infra person after my own heart, it's something that's been kind of long overdue, arguably, but public preview now that we've got the ability to select public IP addresses that have been provided by the customer, that are part of the customer's right ranges. So, if you've got a customer that you're working with or within your business, that is in public previews. Quick screenshot there. That is a link to the blog article. Should be able to click on that link through the PowerPoint if you want to. But yeah, hopefully people find that useful. Another quick one, which I thought caught my eye actually, because I've spent too long playing with KQL and just not really getting it right, and taking the time. And of course, Copilot is absolutely helpful at the moment with trying to write proper KQL kind of structure, even though it is really easy, right? That's what they say. It's really simple, but not for me. So they've introduced this simple mode, which looks quite compelling. I mean, there's a simple screenshot there, but it's really just a real simple way of interrogating some of those tables and really help you build up your query. And of course, you can flick back to full-on KQL mode as and when you need. But for simpletons like myself, it's a nice, easy way to kind of click through and build up your queries without really having to delve into too much detail. And by the way, if you've seen any of these or used any, please do drop some comments in the chat and let us know what your thoughts are, or if you've got any opinions, because I think it would be cool to learn if anybody's seen any of these so far or played with them, or anything else new that I'm not talking about, of course. Next up, quick one on VM hibernation. I know Microsoft, there's certain services we can put into hibernation mode purely from a cost optimization perspective, but there's a couple of ranges of GPU enabled VMs there, the NVV4, the NV ADS ranges of VMs now have got this feature enabled. It's gone GA, and it's purely from a perspective of being able to, like I say, cut costs and not have to pay for that computer. And I believe it keeps that kind of stateful memory as well whilst you do that. So, you can have your cake and eat it too, I guess. You're not paying for it, but you've got stateful VM with that memory kept in tow next time you need to rehydrate it. So yeah, click on the link for a little bit more. And the final little bit of information, which I thought was interesting, was if you're users of Application Gateway at the moment, you'll know that there have been limited abilities to send users off to custom error pages. If you're getting those, you get a bog standard Azure style kind of error page. But now we've got the ability to send users to custom error pages, which, it's a nice simple thing, but it can be quite impactful if you've got an application rather than it coming back with a bog standard stock Azure issue. Then you can send it to your own personalized branded page. So there we go. Nice little format. Hopefully you enjoy it. Gave you a little bit of food for thought there. So we'll see if we can work on that over the coming months. But before we get into the talks, as always, want to quickly shout out our sponsors. So Servant, say it every month, been with us from the start. Absolutely fantastic bunch of guys and gals. Really supportive of the user group community in general. They sponsor a lot of the UK-based user groups. So big shout out to Des and the team at Servant. Like I say, they've been with us pretty much from the start. So about 4.5, nearly 5 years now. If you don't know who Servant are, go and have a look. They are a pure play Azure consultancy practice. I work with them in my day job. And obviously I've known Des for a number of years now because of the support he's given the user group. So just a quick shout out to them. Thank you, Servant, for the support over the years. And also our other main sponsor is locally headquartered company, Credit Safe. Again, I've worked with Credit Safe in a different life, and I've met a lot of the team down there. Great team, really doing some interesting, innovative stuff at the moment, and we've had them on the user group doing specific talks as well. So, again, great to have a locally kind of HQ'd business in South Wales, even though we're not necessarily in person. It's just nice to have that ability to build the community that way for us as well, when we do get back to in person. So yeah, thank you to Credit Safe. And on that note, we'll quickly flick back to our Meet the Speakers page, and I will hand you straight over to Turja and let Turja kick things off with designing multi-tenant architectures in Azure. So looking forward to it. Over to you, sir.
Hey, John. Hello, everybody. First of all, thanks for joining. You can hear me, right?
Yeah, loud and clear.
Awesome. Thank you so much. Let me share my screen just for a second. Let me know. Can you see my screen as well?
Yeah, got you. Perfect.
Awesome. Perfect. Again, thank you, John, for inviting me. Thank you for, first of all, doing this for the community, right? So this is really great stuff that you guys are doing overall for the community, and the education and the reach is all outstanding. Thank you so much for having me. And again, thank you to whoever has attended right now, and also to the people who will, let's say, watch it asynchronously. So a very brief about me is that I am currently working as one of the global platform pre-sales leader as a Big Four consulting company. I have roughly 14 to 15 years of experience. I started my career in Samsung, then I did some work in Accenture, PricewaterhouseCoopers, now in another Big Four. I am a platform engineering and DevOps Institute ambassador. I am a bit of a community geek myself. I lead the Docker group, the HashiCorp group, the Argo group out of the place called Kolkata, from where I am, and I do this regularly. I love speaking to both attending and also speaking at events, right? Because as you said, right, it's like a very nice way to kind of keep up to date, especially in this new world, right, where everything is changing kind of quite crazily. So again, this is just a disclaimer that this is just me speaking. This is nothing to do with the company I represent. I'm not representing my employer or organization in any way. Okay, so again, this, if you see this this session, that presentation I have prepared, right? If you see it, it's not anything new, right? So designing multi-tenancy, multi-tenant architectures, even when I started on AWS in 2015, roughly 10 years back, right? That's when we first did it. So whenever, most of our applications, whenever we are building an application hosted in somewhere which will serve multiple clients, this is something that I think many of us have done in one way or the other. So it's not like I'm trying to show anything new or I'm inventing anything, but it's all good to kind of keep everything, again, kind of like having a recap, having a refresh of what it is this thing is, right? And some of the nuances and some of the, let's say, best practices and stuff like that, because I think this is becoming more and more relevant. And I have some slides at the end that even this agentic AI stuff, right, they will also end up being multi-tenant to some extent, right? Whether they're B2B or B2C. So the overall idea is, okay, what are some of the basic practices, principles, right, that we can follow? So again, 3 sections, some very basic context setting. Then we will go to the meat of the session, which is the multi-tenant architecture section. And then we will just discuss a little bit kind of like a closing thought on SaaS and multi-tenancy, right? How they work together, some of the emerging patterns we are seeing in the industry. So with some context, right, because we are discussing architecture, I just wanted to set the context of like what do we, all of us, right, think that architecture is. It's good to define sometimes, right, some of this stuff, right? So Martin Fowler, somebody I think we all know, and I respect him extremely well, much, and I'm kind of like a follower of his articles, his books and all. So he mostly defines architecture as a set of design decisions that must be made early. Right. So the reason I define this, that I mean, when we say an architecture decision, okay, I made a decision to build my app in this manner 1 versus a manner 2. We always have to understand that that decision was made at that point of time based on the context we had at that point of time. Right. We cannot think beyond what we know at that time. Right. So architecture is always, as you say, it's like a a game of trade-offs, right, at the end of the day. So many of these things that we will show, which I will show, right, in the course of this slides, they might be interesting, they might be, let's say, cool, but at the same time, I mean, when you are designing your solution at that time, you have to design it based on the constraints and the context you know at that time, right? So that's why what we try to say, right? We say that obviously the architecture, the decision of what to do, right? Let's say, should we go with a single tenant model? Should we do a sharding of our database? So the best practice always, as I think all of us will agree, is that we delay the decision till the last moment, because the more we delay a decision, the more insights we get, right, over time, so that we can make a better decision, right? So this is very important, right? That's how I think of architecture, right? Whenever somebody is coming to me, I try to design something which is as flexible as possible, so that even if I get new requirements and new approaches going forward, my change and my delta is less, right? So basically kind of like a sustainable architecture that can stand the test of time. So again, this is just a very high level, and as architects, right, all of us who have done it already, it's just a matter of perspective, right? So it doesn't mean that something is good, something is bad. It's just that we provide more perspective, right? We provide more perspective than, let's say, a developer or an engineer or a tester, right? That's our job as architects, right? To provide a little bit more perspective, think a little bit more about the trade-offs, what is possible, delay the decisions as much as possible. And again, like, this is a very nice thing, right? Why do we need architecture? So if you say, if you think good architecture is expensive, try bad architecture, right? So this is which is actually expensive, right? And I think we might say that this GenAI and this LLMs and this NVIDIA and this agentic AI stack, these are all nice things to have, but one of the things that I have heard very senior people in the industry say is that this AI architecture, this concept of AI architecture, is nothing at the end of that. It's still an integration architecture, right? It's just like different sort of microservices with their own nuances, but at the end of the, it's an integration, right? So all of these concepts that we had, even when we are building web apps, right, for the last 10, 15, 20 years, many of these concepts has stood the test of time. And we can kind of keep relying on those concepts as some of the basic tenets, right, to design even a multi-tenant agentic architecture if need be, right, so to speak. So again, this is just a high-level context setting that, guys, is all a matter of perspective. Right? Obviously, there are some good practices, but doesn't mean that it is what we have to do. Only thing the only advice that we can give others is we should try to build an architecture that can help us delay some decisions that we cannot roll back till the last point possible. That is how I think we should think about architecture as much as possible. With this, I will go to the meat of the discussion, which is on multi-tenant architectures, right? So again, I mean, before we discuss some of these things, maybe again, I think most of us understand what it is, right, to some extent, but so this overall concept of multi-tenancy, right? Again, we relate it to SaaS products more than, let's say, normal products. And I have a section at the end to discuss a little bit about that. I will cover that later. But at a very high level, right? Again, it's like a single instance of an application which is serving multiple customers. And here, customer is a tenant. And now there is this itself is something we can spend a lot of time in, right? Like between a B2B product and a B2C product, the definition of a tenant can be a little bit different. So let's say you are a B2C product, right? Like, let's say ChatGPT, so to speak, right? In that case, you can think that, okay, every single user is a tenant. So I am a tenant, John is a tenant for ChatGPT. I have my own workspace, I have my own profile, my own settings. John has his own workspace, own profile, own settings. So in that way, both of us are tenants. So it's a multi-tenant application. I am a tenant, John is a tenant. But then again, there are some nuances there as well, right? So you will see there are some multi-tenant applications which encourage the group of users into another tenant concepts. So I don't know what happens in the Europe, but in India, for example, some of our telecom providers give us the option, okay, you get your own account, your wife gets your own account or you get a family account, right? So in that case, individually I'm a tenant, or my wife is a tenant, or as a family we can be a tenant. So even in B2C there are some nuances, right? But for the purpose of this session, I'm focusing a little bit more on B2B, because that's where we as enterprise people are mostly focused, right? Most of the products that I have been involved in personally, and many of the people I work with, they're more B2B, business to business applications, right? But again, in B2B also there is a lot of concepts. So one of the very simple things in B2B is, let's say, Salesforce, very well known SaaS application, multi-tenant application. So let's say Salesforce has two customers. Let's give them tenants, right? So two customers. So one customer is, let's say, Bank of America, another customer is Pepsi. So you can say, okay, every single customer company is my tenant. So I have two tenants. But at the same time, let's say Pepsi is such a big organization that Pepsi now says, no, within my company itself, I have so much different sort of CRM policies or supply chain differences that I want within my company also that my HR and my finance are treated as two different tenants, or my region US and my region Europe is treated as a different tenant. Again, why I'm saying all of this is that this is very important. So this is very, again, as I said, this is also a matter of, let's say, perspective and the context that we have provided. So this is very important when we're first designing a multi-tenant application, to understand what is even meant by a tenant before anything else, right? So what is meant by a customer, right? And how that customer maps to this concept of a tenant. So is it like one customer equal to one tenant? Is it like 100 customers equal to one tenant? Like, is it like one company equal to one tenant? Or is it like multiple, even a single company can have, let's say, 10 tenants based on the logical structure of the company, right? So this is something that we should be very clear about. As architects, we need to think about it a little bit. Another thing that normally you will see, that is an expectation from multi-tenant applications, that data is isolated or at least not shared between multiple tenants, right? So this is also one of the, let's say, the core principles of multi-tenancy is that tenant one cannot see tenant two's data, irrespective of the definition of the tenant. That's why I want to keep it separate. So let's say we have figured out what is the definition of the tenant, then tenant 1 and tenant 2 should not be able to see each and their own data. It should be isolated, either logical, physical, whatever isolation will go over that. So these are some very high level thought processes we should take. Now I will kind of go into some of the complexities of multi-tenant application architectures, right? So just by the definition of the tenant, I think you kind of understood that there is a lot more here than meets the eye, right? I mean, it's like I have spent a large part of my time, my career basically, right, designing some of these applications, right, at scale, right? Some of the applications we have been part of have gone out to, let's say, 350, 400 sort of tenants, right? So we have done this to some extent, big applications. So there is a lot of complexity. So as I said, right, I mean, one of the things is that, as I said, right, tenants is basically kind of, you can think of them as customer, but at the same time, because in the context of Azure, it is also very important to understand that Azure also has a concept of a Microsoft tenant or an Entra ID tenant. Sorry, was somebody saying anything? Sorry, I'm not able to hear you. Just a second.
No, I don't think so. I think you're good.
Oh, okay, no worries. Okay, sorry. I thought I saw something. Sorry, I had something. Okay, so it's also very important to understand that there is this concept, another concept of Entra ID tenant or Microsoft tenant or Azure AD tenant, but that is not what we are talking about here, right? There is some mapping. You can actually think that, okay, should my customer have their own Azure AD tenant? Should every customer have their own identity? But again, this is not the purpose of this discussion. So I just wanted to make it clear. So whenever we are thinking of multi-tenancy, right, one of the things that we have understood, right, so there are multiple tenants, right, tenant 1, tenant 2. So here you can see tenant A, tenant B, tenant C, tenant D. With this tenant concept, there is another concept that is very, very important for us to understand if we really want to do this at scale. is the concept of a deployment. What does this mean? So deployment is, at the end of the day, what are we doing, right? We are deploying some resources in Azure, which will have our data, right? So we might think that, okay, in a single tenant model, every single tenant will have its own deployment, or in a pure multi-tenant model, all of every single tenant will share their data within the same Azure resource. Let's call it a single Azure subscription. But to really think of this at scale, we need to be very clear with this concept of a deployment. So a deployment is nothing but a unit. There is even more complexity even within a deployment, but for the simplicity's sake, you can think of a deployment as an instance of your application. So it's an instance of your application that you have deployed. So as you can see here, this is deployment 1. It has a web server and a database. And then there is a deployment 2, which is another web server and database. In similar way, you can have multiple deployments. You can have 4 deployments, or you can have 1 deployment. So if you had 4 deployments, then you could have said, okay, every tenant A will be mapped to deployment 1, tenant B will be mapped to deployment 2, tenant C will be mapped to deployment 3. You could have said that. Or if you had only 1 deployment, then you could have said all 4 of these tenants A, B, C, D will be mapped to a single deployment. But why I want to make this very clear is that no matter which model I keep on showing in the later slides, we need to understand that there is these two are two different things. So we should not confuse the customer or the tenant with the actual deployment instance of our solution. So the left is the customer, the right is the actual instance of the solution that we have deployed. And the moment you can visualize this as 2 different things, then it leads to a lot of interesting use cases. Like, for example, you can see here what it is trying to show, that A and B, these 2 tenants are deployed in this deployment ID 1. And C and D, these 2 tenants are deployed in this deployment ID 2. Okay, so this I think is called vertically partitioned multi-tenant models. I will go over this pattern also later. But why I want to focus on this part for a little bit is for us to understand that there are 2 different concepts. We have this concept of a tenant, which all of us, I think, agree to some extent. But then there is also this concept of a deployment. Even if you think of a single tenant model, then also you should think of it in this way. The only difference in a single tenant model will be every tenant will have its own deployment. So if 4 tenants means 4 deployments. That is the only difference. But I still want all of us to think in that way, because then you come up with this tenant mapping sort of a structure. So whenever a customer is coming to the landing page or to the ingress controller of your application, however way we want to think it, this tenant mapping will basically map based on some metadata or hashing that, okay, this tenant A will be in deployment 1. So let's go to deployment 1 to serve the request. So that is the overall idea. So very important to know there is a concept of deployment. Now, the another very, very important concept is this concept of isolation. So concept of isolation is how isolated do we want to keep the data or the context of each of the tenants. So again, we have 2 different extremes. So we have full isolation. Full isolation means nothing is shared, right? Everything is separate, as you can see, separate compute, separate database, separate networking, separate domain names. And at the right, you have full shared model, which is everything is shared. And then in the middle, you have some hybrid models, right? So this hybrid model is shared compute, shared database, shared networking, shared domain. Now this itself is a business decision even before it's an architecture decision. As an architect, the decision of whether I should do it as a fully isolated or fully shared, or I should do something as a hybrid, first needs to come from the business requirements. The business needs to tell me what are some of their constraints. For example, some of the government clients might say, okay, no, I cannot have anything even in the same network as some other client. It's anyways goes to full isolation, right? So this requirement will come from the business. Once the business gives us the requirement, we then need to map it to one of these isolation model and one of the architecture patterns that I will mention in the next slides. So this is something I think all of us are normally very comfortable with. Many of the applications, when they start, they basically start in this model. This is a very simple single tenant deployment. So if you again come back to here, this is the deployment where every single of these tenants has one associated deployment ID. So here you can see tenant A has a deployment ID, deployment A. Tenant B has a deployment ID, deployment B. Tenant C has a deployment ID. This is very simple, right? I think all of us kind of understand this in a very logical way. It's very easily understandable. It has some positive, some negative. I think we all understand the positive is full isolation, right? So tenant A is completely separated from tenant B because I have set up a completely separate isolated deployment instance just for tenant B. But at the same time, there is some cost as well, right? Because now I am not sharing anything. So there is again some good thing is that because you are not sharing anything, you will not hit some of the Azure subscription numbers. And trust me, in a pure play SaaS sort of an application, there is a high chance that you can hit some of the Azure subscription limits, right? If you keep all of your tenants in the same subscription. Here, the good thing is every single tenant is getting their own subscription. Very unlikely you will hit some of the limits. But at the same time, to do something like this, there is very, very important that you have a very, very strong multi-tenant control plane. I will go through that in a separate slide where I will go through the control plane. But you have to understand, right? Just imagine in this slide, I'm showing 3 tenants. Just imagine there are 300 tenants, right? 300 tenants. So then you need some sort of an orchestrator or a control plane sort of something which will manage the upgrades, the patching of all of those tenants. So these are some of the things we need to keep in our mind when we are doing something like this. Similarly, how do we get the consumption metrics? So for the entire application, if I want to understand, I need to understand the consumption metrics across also. Again, the control plane acts as an aggregator. So there is a lot of things that a control plane needs to do. So in a single tenant deployment model, your control plane has to be very powerful. It is the orchestrator. It is the thing that deploys the tenant. It is the thing that retires or decommissions the tenant. So whenever we are thinking of this sort of a model, obviously we will have our automation and isolation, but we also need to think about the positive and negative and the control plane concept. The other one, which is at the other extreme, is a fully multi-tenant. So this one was single tenant. Every tenant had their own deployment. In this case, all of these tenants have a single deployment. So everything is shared, right? So again, logically speaking, in this way, you really don't need a very, very strong control plane, right? Because tomorrow, if another tenant also comes, that tenant will in a way also exist in that same deployment. So you don't need to instantiate again and again. But obviously, you now need to put more focus on how you can do some sort of isolation at this shared deployment. So for example, how do you, let's say, separate tenant A data and tenant B data, even though they are on the same database? So do you use row level separation with a tenant ID as an identifier or a primary key? Do you do schema level isolation, right? So there are different patterns we can follow. But the idea here is that the other model, this model is very good to start with, right? But over time, this model has a lot of hassle, right? Especially if you don't need it because you are deploying again and again. For every single customer, you are deploying a completely separate instance. The cost also becomes a little higher. In this case, the cost could be a little lower, but at the same time, you need to put in more effort at the individual isolation level. So now you need to have some sort of a logical abstraction or a logical layer on your billing or your consumption so that you can very nicely say how much of the shared resource the tenant A consumed versus how much tenant B consumed. So now this becomes a logical abstraction because you cannot abstract in an isolated in an isolated manner or in an absolute manner. You cannot abstract because everything is shared within the same sort of a deployment model. Now I was telling you about that vertically partitioned deployment model. So the vertically partitioned deployment model is also something I have seen in my own work as well. So many times what will happen, right, that people will start with this sort of a fully multi-tenant deployment, because this is sometimes a little bit easier to do, to be very fair, right? Because you really don't need to think about that control plane and the provisioning of a tenant and the decommissioning of the tenant and the tenant life cycle that much, right? Not, at least not from an infrastructure provisioning perspective. So people sometimes will start from this, but then a client will come and say, no, I am not okay to share. I need a full isolation, and I'm okay to pay whatever is I have to pay to do that. That's how this fully multi-tenant kind of evolves into a vertically partitioned. So if you see this tenant A and tenant B still kind of stays in that fully multi-tenant sort of a model, but now this tenant C becomes that single tenant sort of a model. So this is kind of in a way hybrid to speak, but again we call it vertically partitioned, because now what you have two flavors within your same solution. But now what is the complexity? The complexity is the code. Now your code needs to be flexible enough, because you will write the code only once. You will not have two different packages, one for deployment 1, another for deployment 2. You need to have the same Docker image, or you need to have the same Helm chart or the same DLL that can be deployed both on the deployment 1 web server and on the deployment 2 web server. So now that logic has to be intelligent enough that it should not matter whether you have deployed it in the deployment 1 or in the deployment 2. Right, so your tenant mapping and all of your logic has to be very, let's say, abstracted. So all of these concepts have to be abstracted. So for example, if you have in this model, right, tenant A and tenant B, let's say, are sharing the same web server, right, and you are using some sort of a, let's say, authentication token to authenticate on this web server, and in the deployment 2 you are thinking, no, I will do completely different authentication, that will not work, right? Because you need to ensure that the same sort of code you can deploy in both models, basically both in the left and in the right, right? So these are some of the things we need to keep in mind, because many times clients will come and say, okay, I will have my own deployment. Now you integrate it with my own identity provider, completely separate, because then you are kind of moving away from that sort of a multi-tenant architecture in concept. Some of the concepts, and again, as I said, we can do whatever we want in isolation, but when we are thinking of doing something at scale, there are some of these patterns and best practices that we need to follow. So at scale, if we want to do these vertically partitioned deployments, we need to still ensure that the code base, the actual code base, is still can be deployed both on the left and on the right. So this is vertically partitioned deployment. The other one that I think many of us are very, very comfortable with, which we have seen, is horizontally partitioned deployment. Again, I will say this is another variation of the fully multi-tenant deployment. But when I say variation, the only thing is that the database we don't want, or the data layer, the persistence layer, we don't want to share. Whereas the non-persisting or the stateless layer, which is this web server layer, that is something we are okay to share. Mostly you will see applications are like that, because you are not storing any actual data in this web server layer, right? It's more like a pass-through. It's some sort of a business logic or a front-end logic, right? Client-side logic. So here what happens, the web server and sometimes even the middleware server is shared across all tenants in a full sort of multi-tenant, whereas the data layer or the persistence layer is basically isolated. So tenant A, tenant B, tenant C. This is also a very, very popular sort of a model. If you ask me, when people are starting, as I said, right, people are starting from this sort of a model, quickly they will move to this sort of a model, because this model is still, there is some complexity in this model versus this model. The complexity in this model is you still need to have a, let's say, quite good enough control plane, because the moment you have a new tenant D, your control plane needs to be able to run some automation to set up the tenant D database, right? Because that is something you need to, so the post provisioning and even the decommissioning, right? The entire tenant life cycle. So the control plane is very, very important. Whenever we are thinking of this sort of a situation, we need to think that manually we can set this up, right? Manually, whenever a new tenant is coming, I can set up a database, but that will not scale. So I need that control plane, that orchestrator, that whenever somebody will onboard a new tenant, it will create the database, it will put in the seed data, it will set up the URL, it will set up the traffic manager instance if needed, everything it will do so that all of this setup is done. So this is a horizontally partitioned deployment. So before I move forward, I don't know, John, whether there are any questions that I need to answer here, or should I just move forward to the next section, or how do you want to do it?
I can't see anything in the chat at the minute, Turja. So yeah, no, you carry on.
Perfect, perfect. Thank you so much. So if you see what I'm showing here, as I said, right, this is nothing new. This is nothing that I have, let's say, researched on my own or I have built. These are all very standard models. And just to reinforce that part, right, that this is the same thing, I have just also put in some slides on how Azure's counterpart, Amazon Web Services, also thinks about multi-tenancy. And if you see, they have used different terms, but the concept is same. So this is in AWS terminology. They are talking about these two models. One model they call silo model, another model they call pool model. If you see this silo model, every tenant has their own instance. So if you compare this silo model, this is nothing but our single tenant deployment model. Same thing. They're just calling it silo model in Amazon terminology, right? Similarly, if you now come to this pool model, right, see, everything is shared. The app tier is also fully shared, and the data tier is also fully shared. Obviously, they have put in some sort of a logical isolation, right, at a schema level or some other level. But if you see this pool model is nothing but this fully multi-tenant model. Okay, now if you come to this bridge model, what they're trying to show in this bridge model, it's not coming out in that way, is that the bridge model, what they're trying to essentially show is basically the horizontally partitioned deployment, where the web server is shared, but the data or the persistence layer is basically duplicated. So see, tenant 1 schema, tenant 2 schema, tenant 10 schema, and again, they have done it in a schema base because they're showing from an RTS perspective, and the app tier, as you can see, is shared. So here they have full 3 RDS, here they have a schema, and here within one schema only, they have done a partition based on, let's say, some sort of a row level partition or something. So again, same sort of conceptually, this is very interesting that all of them are thinking in the same way. Some of the architectural trade-offs, again, as I said, right, as you move from the silo model to the pool model, and obviously in the middle you have this bridge model. The silo model, one of the pros is, as I said, there is no cross-tenant impact. So there is no noisy neighbor problem, right? If tomorrow one tenant comes and says, Turja, you give me more power, more juice, you can give that, so to speak, right? Because they have their own deployment. You can juice it up as much as you can kind of say. Any sort of governance, compliance, isolation, everybody's happy, right? Because nobody else has access to it. But one of the cons is, as I said, right, there is a deployment complexity. What if it increases from 3 to 300 to 3000, right? Then you need to have a very strong control plane. Without a strong control plane, the silo model will fail for sure. You cannot manage it at scale in a manual manner. There is this concept of a cost, right? So the cost is also higher, much higher. In some cases we have actually seen it's not that high also, depending upon if it's a fully microservices architecture with S3 buckets and DuckDB and all. So there is some other optimizations we can do in the silo model. But in a normal 3-tier legacy sort of an architecture with a full-fledged SQL or a PostgreSQL database, yes, the cost can be a little higher. If you come to the right, which is the pool model, as you can understand, the deployment is a little bit easier because you are not having to deploy new instances and update and all of that, right? New URLs, nothing. Is the same thing, more like logical abstraction. But some of the cons is, as I said, noisy neighbor problem, right? How do you give each and every tenant its own customized URL? If tomorrow a customer comes and says, okay, I want to buy your product, but I want a custom front-end page with my logo or my JavaScript or some, right? Then you need to do a lot of fancy coding, right? To ensure that the website is so dynamic, right? If you had your own isolated instance, you could have just gone ahead and done whatever they wanted with the front end, just as an example, right? So this is then, but at the same time, if your web layer goes down, all tenants or all customers will feel that that thing is going down, right? Because even a small update. So as I said, right, even a small patch update, if it is not correct, will put down the entire thing down. So all of the customers who are directing to that shared deployment instance, if the deployment instance is down, all of the customers will not be able to access it. So these are some of the things we need to keep in mind. So again, the same sort of concept that we are just trying to show it from the perspective of these are all AWS images, silo isolation, this is the pool isolation, and this is the bridge isolation. So again, the same thing that Microsoft Azure is doing, Amazon is kind of saying the same thing. And if you go to the Google documentation, they are also kind of similarly saying similar sort of stuff. Now, another thing, I put a AWS image here because I did not find a very nice Azure image. So this is where I think many of us, at least the people who are beginning, right, like not very experienced, I have seen, they stop at that isolation level. That's where they think, okay, I have figured out the isolation. That means I have developed a multi-tenant application. Multi-tenant application.
That is not a hat
Yeah. Can you guys hear me?
Yeah, still got you, Turja. Yeah.
Yeah. Okay. I heard some, but anyways, so what I'm trying to say is that many of the people that if you normally speak to, even when I take interviews of people with 5 to 6 years of experience in Azure and I discuss this aspect, they will mostly focus on a. So if you ask them to kind of tell you about, okay, what is a multi-tenant application, what are some of the things you need to think about when designing a multi-tenant application, they will always focus on this isolation, and they mostly get it right to a level, right? But a multi-tenant application has a lot more nuances other than that. For example, one is managing the life cycle of a tenant. So how do you register a new tenant? How do you onboard a new tenant? How do you decommission a new tenant, right? When a tenant is not needed, when a customer is getting out of your application, when they're signing out, when they're saying, okay, no, I don't want to pay for your subscription for next year, how do you automatically decommission that tenant? How do you provide trial tenants? There are many customers who will ask you, okay, I need a trial. I want to first try out your application. So how do you provide a trial tenant? How then after the trial is over, if the application, if the customer wants to move to production, how do you convert the data of the trial tenant? How do you convert basically the essence of the trial tenant into a full-fledged production tenant? These are all these are very complicated stuff, right? When you actually get into this, sometimes you will see the isolation part was easier than this life cycle part. And that's what I said, right? The more isolated deployments we are doing, right, the more you need that control plane to be strong, because it is the control plane which will have all of this logic. Somebody has to write this logic, right? That, okay, how when a new tenant is getting, so let's say the for a SaaS application, just to make sense of it, for a SaaS application, a customer has reached out and let's say said, okay, I want to onboard to your customer either via self-service or they reached out to your sales executive and they go to the admin screen and try to add a new tenant. So all of that is happening in the control plane. There's a lot of automation that needs to take place in the back end to ensure that you have a new tenant, you have the deployment of the solution mapped to the tenant, right? All of those deployment ID and tenant ID mapping that I was talking about, all of this needs to take place. And not only onboarding of the tenant. I have seen people take great care in onboarding the tenant, but they kind of lose the ball, right? Or drop the ball, right? When they're doing the tenant, they don't focus on the tenant decommissioning, the tenant deboarding, right? How do I move people from one tenant to another tenant? So there is another concept, I have not gone through it in that. So there is a concept of tiered deployment. So bronze, platinum, silver. So let's say I have onboarded to a SaaS product with the bronze layer. I'm just paying $5 per user, right? And I'm getting, let's say, 20 functionalities out of the total 100, right? Now I want to move up to the new tier, which is from bronze to silver. And I will get, let's say, another 40 functionalities will open up for me. So that is something. So I will just click as a user, I will just click on that upgrade button, right? And I expect all of this to happen in the backend. The moment I click on the upgrade button, right, I need to think, okay, is there a new tenant which is for this higher tier? How does the control plane take all of my data, my deployment data from this tenant 1 to the tenant, higher tenant, from the bronze tenant to the silver tenant at a high level. Some of these concepts are also very important and we should think about this concept. So this is the tenant life cycle, which is very interesting. And as I said, right, to do all of this, you need this control plane. So the data plane is where the data is staying, right? So whether you have isolation, full isolation, like the silo model, or you have the pool model, which is like the multi-tenant kind of, not like everything shared sort of a model, the data is still residing in the data plane, right? Whether you have multiple data planes, as in multiple tenants, or you share. But you still need a control plane which will ensure the management of the tenant, the onboarding of the tenant. It will track the consumption of the tenant, right? It will ensure some of the basic security policies are injected in every single tenant. It will ensure the metrics from each of the tenant will bubble up and you can see a dashboard which will show, okay, the tenant 1 is using 60% of the resources. Tenant 5 is using 80% of the resources, right? So this multi-tenant control plane is very, very important. If you don't have a good control plane, and we have I have faced this in a how to say, like in a bad way, right? I actually paid the price for not doing this, because initially business will not want to pay a lot of money to build this control plane, right? Because this is not giving them the customer is not staying on this control plane. So the business only thinks, okay, the customer needs to pay, right? If the customer has to pay, then I need them to be on the data plane, right? So the business will always try to focus you to build a more stronger data plane, add more features. But without a good control plane, you will not be able to scale this. And if you compare this with the Kubernetes clusters, right? Let's say the Azure Kubernetes service, they also have a control plane, right? It's abstracted to us to some extent, but they have it, right? It's not that it's not there. So most of the popular SaaS services, right, or anything, even platform as a services, right, PaaS sort of services have this inherent, even APG in Google has an inherent control plane, so to speak, right? So it's very important that we think when we are architecting about this additional concepts. We should not, as architects, just end our multi-tenant architecture at the isolation and say, okay, our architecture is done. We should also think about the tenant life cycle. We should think about this control plane and so on. The other thing as architects, we also need to think about to some extent, again, all of these requirements might come from the business, but as an architect, I might still need to architect that, right, into my solution. So another thing that we need to think about for multi-tenant applications is the pricing model. How are we planning to price this? For example, these are some very, very common pricing models I've shown here, like consumption-based pricing, which is very, very popular, right? Like how much you consume, I will just put some sort of a markup on that. User-based pricing, that is also something very popular, right? That is actually how most of the SaaS companies today are asking us to pay, right? Kind of called seat-based pricing as well, right? You buy a seat of that SaaS company, for example, ERP, SAP, right? You basically, even if you don't consume, you still need to pay for the seat of that or the license kind of, and then obviously per active user pricing, and you can take it to a huge different level. There is a lot of bandwidth and a lot of cool stuff that is happening here now. I don't know if you have seen that with this agentic AI, there is this new concept called outcome-based pricing. This is a very, very recent model that has developed, which many vendors are kind of trying out, where they're saying, okay, you will only pay. So if I have a call service agent, I will only pay the price for that call service agent if there is a successful outcome. A successful outcome could be I have positively responded to the request from a customer. So it doesn't matter about my consumption, doesn't matter about my licensing. I will only pay if I have a successful outcome. So the only thing I'm trying to kind of explain here is that as an architect, there is a lot we have to actually do at this level as well. I'm not saying that we need to come up with the actual numbers. That's more the job of the product commercial team, right? The commercial hub team. But based on all of these different sort of nuances, right, of your architecture and some of these requirements that will come from the business, that will end up influencing your architectural pattern as well, right? So if you have a full-fledged, let's say, if you have a full-fledged isolated or let's the silo model, right, or the a single tenant deployment model, you will never be able to implement an outcome-based pricing. Because if you deploy an outcome-based pricing and the outcome is not achieved, right, there is no way for you to recover the cost because you have a full-fledged single deployment. So there is a lot of stuff that we should think about this as well to some extent. And this is something I told, right, I had one slide on this concept of a tiered tenant tiering, right? So there are different tiers that we can have. So for example, there is this concept that, okay, I have a silver tier and I have a premium tier. So the silver tier means that I will have to share, the cost will be less obviously than the premium tier or the gold tier or the platinum tier, but multiple tenants will share the same infrastructure. So that is the silver tier. But now let's say I start on the silver tier, but then I say, no, I want to now upgrade to the premium tier. So the moment I upgrade to the premium tier, I will have my own tenant. Or let's say at the same time as an architect, I also need to think, what if somebody who is in the premium tier wants to downgrade to the silver tier? Can I really do that? So these are all very, very important things that we need to think about when we are doing this at scale. So the isolation is not the only thing that is important for a multi-tenant application. We need to think about the, as I said, the life cycle, the tiering, right, the cost models, right, the control planes, and all of these aspects. Now I will very quickly, I don't have a lot of time as well, but very quickly I will kind of say that the design I showed you was at a very high level logical sort of a construct, right? I was showing just boxes, but the same concepts you can apply at every single Azure resource level. So if you see here in Kubernetes multi-tenancy, if I deploy the single tenant deployment model, you see every single tenant has their own deployment. Every deployment has their own cluster and a database. This is a single tenant. The moment I say a fully multi-tenant deployment, all of these tenants will share the same deployment. That means they will share the same AKS cluster and they will share the same database. Now, the moment they will try to share the same AKS cluster, you might do it at a namespace level. So that is where it gets interesting. So this high-level architectural guidance can provide you the logical model, but then how do you implement it is dependent upon the Azure resource. So when you need to implement a fully multi-tenant model or a fully multi-tenant model with this sort of a pool isolation, right, on an AKS cluster, you might still have a single AKS cluster, but now you might want to do the isolation at a namespace level. Similarly, you might have the same database, but you might want to do the isolation at a schema level, right? So this is the concept. So, and this will vary from service to service. So one Azure service like AKS cluster is giving you this concept of a namespace. Something else might, like a service bus, might give you the concept of a topic. You might say, okay, tenant 1 has a topic 1, tenant B has a topic 2. I'm just saying as an example, right, within the same SNS instance. So there is some thought process we need to do as architects on how we can map these high-level concepts, the logical concepts, into the actual Azure services. So again, this is namespace driven. So this was basically the meat of the session, which is the multi-tenant architecture. Before I move on to the third and the final section of the session, just wanted to ask John, is there anything that you want to ask or any of the audience wants to ask, or I can move to the next part or the last part of the session?
I don't think we've got any chat questions. No, if there's anything anybody wants to ask, please do pop it in. Yeah, no, carry on as you are, sir.
Thank you so much, John. Thank you. Perfect. So in the last part, right, I just wanted to kind of tell you that why this is important. Obviously, this was always important, but why is it now, like, let's say, even more important to some extent, or even at least equally important? So if you see overall, the SaaS software market, right? And as you all understand, right, whether it's a B2B SaaS or a B2C SaaS, SaaS by the nature of it has multi-tenancy as one of the aspects, right? So if you see consistently, there is a trend that the SaaS business will grow. And when this business will grow, all of this AI agentic or the vertical AI agent business is also kind of included here in this research. But you can see it is consistently growing from 300 billion worth of business that SaaS does today to roughly 1,200 billion in the next 1,000 billions, 200 billions in the next 10 to 11 years. So that means SaaS or some flavor of SaaS, let's call it, is there to stay and is only getting stronger over time. So that is one part. These are some of the top SaaS companies that we already know about, right? And you can see that they are making some really good money, right? These are like big companies, Salesforce, Adobe, these are big companies. One thing we need to understand, right? So SaaS by itself is much more than just a multi-tenant architecture. So it's more like a business model. There is a lot of other stuff that you need to get right when you have to deploy a SaaS application, right? Like a lot of product management, market fit, many other things. The multi-tenancy part is just a part of it. It's a very important part. Without that part, unless and until you get that part right, you will not be able to, let's say, continue developing and deploying your product basically at scale. But many companies, whenever they say SaaS, they will equate to a multi-tenancy. Whenever you think of multi-tenancy, they will equate to a SaaS. That is not the nature, right? Every single multi-tenant application does not have to be provided as a software as a service. So a software as a service has some other characteristics, right? That has to be met to be called a solution as a SaaS. It doesn't have to be that every single multi-tenant application has to be delivered in the SaaS business model, but mostly every single SaaS business model mostly has a multi-tenant deployment model, even if that multi-tenant deployment model means deploying a single instance per tenant. That is also called multi-tenant deployment model. Even if you're deploying a single instance per tenant, you might call it a single tenant deployment model, but actually still part of the overall multi-tenant deployment model. Just that in that model, every single tenant is getting their own deployment, like I showed in the beginning. That is very interesting. So as I said, SaaS is just a whole thing. It has a lot of other stuff. It's more like a business model with a lot of stuff, whereas the multi-tenancy is basically a very important part of that, right? And as I said, right, when you are developing the multi-tenant stuff, onboarding, management, the billing, the metering, the metrics, the analytics, identity, we did not even cover some of this, right? Because then it will take another 1 hour, right? Just to cover the identity aspect, the authorization and the authentication, whether it is attribute-based authentication or identity-based authentication, the metrics and the analytics, right? So there's a lot of other stuff that we need to think about, especially when we are doing some of these things at scale. One thing in this interest, because as John was saying, we are just wrapping up some of the information from the NVIDIA work sessions. So one of the things that will come up more and more as we are developing this sort of GenAI applications or agentic AI applications is how do we also think about multi-tenancy for these LLMs. So by itself, that's a big concept. So we can go through that, but this is just one of the thought processes where you can see every single tenant ends up with their own OpenAI instance. So this again, you can relate it back to your subscriptions, to your single tenant subscription deployment model. So that is what is this dedicated OpenAI per tenant. Similarly, this is another nature I wanted to show. This is something where you can see that these are multi-tenancy for AI ML projects. So for AI ML projects, the final output is a model mostly, right? The model. So if you want to have a model which is multi-tenant, then one of the thought processes could be, okay, my model 1 will be trained only on the data of tenant 1, and my model 2 will be only trained on the data of model of tenant 2. So as you can see, the tenant data here is the kind of the logical factor, the separation factor. So the tenant A data is influencing the model output for tenant 1, which is used by the tenant A users. The tenant B data is being used by them, is generating the model output for tenant B, which is used by the tenant B users. So these are some of the approaches in which we can think about multi-tenancy. Obviously, there is a lot more complexity, especially with agentic AI and all. And last thing that I wanted to kind of also discuss, right? So there is this lot of concepts, right? That okay, AI agents will kind of take over SaaS, right? Again, I mean, even Satya Nadella, I think in one of the workshops said something along the same lines. He did not say the same, this thing, right? He said basically that there is a, in its normal way, it is kind of dead, right? Because these AI agents will do some of that work, but doesn't mean that the business model is dead. It means that some of those companies will now have to innovate, right, and create this vertical AI agents as part of the stack. But the business model and some of the problems that are inherently coming with those business models, like as I said, right, the multi-tenancy, the onboarding, the life cycle, those will not go away, right? So whenever we are having an agentic AI sort of a system, right, or I have deployed multiple AI agents at scale, right, then I need to think, okay, how do I separate the long-term memory of agent 1 from the long-term memory of agent 2, which is agent 1 is on client 1, let's say tenant 1, and agent 2 is on tenant 2. So the same sort of architectural trade-offs and the architecture considerations that we were doing with this traditional sort of SaaS models kind of are still relevant in this vertical AI agent sort of a business model. So this is also something that is interesting, and I think that was the end of my slide. I think we are also kind of okay on time, John, I hope. So anything else that you guys have on your mind, more than happy to answer, but this was kind of the end of the actual session that I had, the actual content I had. So I'm just stopping.
No, fantastic stuff. Thank you very much, Turja. Yeah, definitely a lot of, good, valid food for thought pieces that you've just been through there. So yeah, let me just quickly chat. I don't think we've got any questions. Have we? No, there's no questions in the chat at the minute. But look, if you think of anything later, please drop it in the chat. And Turja, I know it's late with you now, so appreciate your you coming on tonight. So look, if everybody wants to show their appreciation, thank you very much, sir. Really appreciate your time and coming on and teaching us all about your learnings as well.
Thank you so much. Thank you, John. Thank you, everybody.
We'll catch up. Obviously, it's late, but feel free to stick around if you really want to, and you can join in the quiz. Absolutely fine. But look, we'll move hastily along now. We're a little bit running over. It's not a problem at all. So, Maik, if you are available now, we will just hand straight over to your session, sir.
Yeah, so you should be able to hear me now.
Yeah, got you. Nice to see you, sir. How you keeping? All good?
No, not that bad, but I've been sick the last 3 days, so I hope my voice keeps running through the session, but we will see where we end up. No problem at all.
Okay. Look, I'll let you take the floor. If you want to share your screen, you can.
Let me just start by
jump
sharing my screen. So let's just kick in. Is it coming through?
Yeah, see it all good.
Great. So let's just get started then. So guys, we're going to talk about empowering your organizations with reusable Bicep modules and automatic deployments. We're going to do that from a specific scenario, but first, let me just introduce myself a little bit further. Like John said, I'm Maik van der Gaag. I currently work as a CTO at a company called 350. And 350 is a consultancy company in the Netherlands, where we do mainly consultancy work in and around the Microsoft cloud, may it be Azure or may it M365. And next to that, I'm also a Microsoft Azure MVP. At the end of the session, I saw a lot of interaction from you guys coming from sending a reaction to the session from Turja. So before I further deep dive in the session I will be giving, I want to ask who has experience in writing Bicep, and if everyone who has experience could raise up their hand. Couple. Oh, I just. Okay. So let's say about 50% of the people that are joined now have some experience. So that's fine. because of course, I'm going to show you some Bicep files and some Bicep code as well. I'm not going to deep dive in all the possibilities of Bicep because that would be a very large session to combine those two. But let's first start and look at a scenario. So imagine yourself that you would like to build a web application and you want to use some Azure resources. So if you look at the picture we have here, we have an Azure function, we have Azure app configuration, and we have a Cosmos DB. So basically, if I would have this application, I would need these resources, and you would really want to start with using infrastructure as code. And by all means, of course, Bicep in this example. You would start by writing your files and creating those resources. But most people start by just doing it manually through the portal, because it's that easy in the portal nowadays to just create your resources and combine those in your application. Most people do that manually, but then a problem begins. So your organization grows from time to time. So from application 1, we're also building application 2. In application 2, we also need an Azure function. And we need a SQL database instead of a Cosmos DB in this example. And now you again need to go to the portal, create an Azure function, and create a SQL DB. And in a few months' time, and I think you can already guess what happens then, is your organization grows again. And then we also have application 3 and we have application 4. You see some shifting in Azure services, but you see also some services that are alike and could be reused. So creating these services every time by hand would be very problematic. Even setting all the correct configurations, maybe also configuring authentication, and all the security compliance rules an organization has could be very problematic. And even when doing it manually, could be very risky because things will be forgotten by people, leaving your environment insecure and everything else. So this is basically where infrastructure as code comes in to help you further streamline that process that you have in building your applications and moving it to the Azure cloud. So that basically brings us about what is Bicep. So basically Bicep is an infrastructure as code language, and it's called a domain specific language because it's built specifically for a specific domain. And as you can see in the image, it's a transparent abstraction on top of Azure ARM. So basically what it does underneath, if you build your Bicep files, you construct, of course, Bicep, but underneath, when you try to deploy it, it translates it to Azure ARM, and that specific part, so the Azure ARM itself, is sent to the Azure Resource Manager. And that's basically the top layer in the Azure platform, and that top layer only speaks ARM. That's very important to know, that there's something magically happening in the background as well, because I think I saw 50% of the hands that already know Bicep. Does the other 50%? So let me do another interaction with you guys as well. Do you guys know ARM as well? And then just raise your hands again if you. Yeah, okay, I see some more hands now popping up. Yeah. Okay. So basically, if you are still using ARM, stop using it. That would be the best approach because Bicep gives you much more flexibility and options in working with stuff. And that's basically where the main pointer of this session is coming through, and that's basically around Bicep modules. So if you're able to write Bicep, you could also use the Bicep module functionality they have constructed in there. This was something that wasn't really possible when using ARM. You could use it, but then you needed to save your ARM template in a storage account, and you needed to use an account key to get that ARM template locally and then be able to deploy. But they've now built and constructed something in Bicep to do that for you. And basically what it is, it's just a regular Bicep file. Nothing fancy, nothing different as well. Basically, the only thing that you need to be aware of is that you have parameters that you can use to supply your input variables, and you have your output variables to specify an output of your module as well, so that you will able to chain everything to each other. What's important to note as well is that when you use a module within your Bicep file and you construct that to your ARM template, what it does underneath, it's just a regular nested deployment. So there's in the background, that's nothing fancy. Yassine, I see that your hand's still raised. Do you have a question? And I can answer it right away, or do you just kept it raised? So let's start by just first dive into some Bicep code. So what you guys see here is my Visual Studio Code environment, and I've just opened up one of my demo repositories, and I will share the links at the end of the session, because all this code, what you will be seeing here, is all on GitHub, so you can easily reuse it, do with it what you want, you name it. But to let you see how easy it is, let's just start by creating a Bicep file. One of the most important things is when you start writing Bicep is to be sure that you have the Bicep extension installed for Visual Studio Code, because that will help you a lot as well. The main thing we need to start with is just the resource keyword. And you see already GitHub Copilot kicking in for me, because I've got Copilot installed on my machine. But let me just ping this out. And what you see here is that, and that's basically the very beautiful thing about writing Bicep. The intelligence in Visual Studio Code as well is very easy and helps you a lot in writing your Bicep. So let's just get started. Let's give it a name. I thought I had problems with my voice, but I have more problems with my fingers today. So now I have something very easy. I have a storage account. What you can see here as well, that I still have some problems here. So I do a quick fix, and it directly adds for me the required properties that I need to have, and since source group location, I really have problems with my fingers today. So as you can see here, it's very easy to just get started and get everything up and running. Now I just have a simple Bicep file. If I would give this simple Bicep file a parameter, and I would say location, string, and just let GitHub Copilot help me, and then I can remove this one and move it here. So, and for example, I can also give it a parameter, and I do it, let me just call it name. I don't like storage account name, and I don't give it a default value, and then I can replace this by name. So what I've done now is that I've created a Bicep file for a storage account, of course, by defining a storage account resource, and I've given this file, for example, 2 parameters. 2 parameters so that I have input parameters for this specific Bicep deployment file. And what I can do also, I can also do, and that's where where is the endpoint? Just to I can also specify the output parameters so that I can get something out after my deployment. So now I have just a regular simple Bicep file, but I can also see this file as a module. So for example, if I would have a new file, let me just call that main.bicep because that's my application name. I can, instead of typing resource, I type module, and then I give this a type safe name, and I call it account. And you see already here is that the Bicep extension is helping me in what I want to do, and it already shows me the other storage.bicep file. So I can click that. Again, I have to fill in the name. And you need to be aware of the name that you are filling here is the name of the deployment itself that it will send to Azure. So it will not be the name of the resource, but it will be the name of the deployment, and the name that I'm now filling into the parameters will be the name that is the input parameter basically of my module. You don't see any red squiggly lines because I've filled in all the required properties. But as you know, on the storage.bicep, I've also got a parameter location. But as it's not required because it has a default value, it will not show up. But I can also, of course, use the IntelliSense and fill in what I want for that as well. But let's just keep it as a default value. So this is basically how easy it is to get started in writing reusable stuff, because the storage.bicep file itself is now completely reusable. I'm not sure if I should say this, but I could send this file to everyone within my company, and they can reuse that same file in their main deployments. Or we could do it a better way. Let's find out during the session. So to give you some more ideas as well, in this folder I also have some other modules created. And what you can see here is, for example, if I open up the function app, and as many of you may know, a function itself consists out of multiple resources. So you have to have the server farm, you have the function itself. Maybe you would also like an application insights or something else as well. And in this module, what you can see here is I have some metadata just for information. I have my input parameters, and then I have the resources itself. So as you can see here, I have a server farm, and I have the function app itself, and I also do some site configurations afterwards. And even the storage account as well is also contained in this module. So this could basically be used as a function-specific module so that people that need to create a function do not have to think about random questions, random security thoughts. Now you can completely construct this Bicep file to comply to specific things. So let's jump back to the slides. Yes. So yeah, what I've showed you guys is that okay, we can create modules with Bicep. Then we have, for example, a modules folder where we can save the specific Bicep files. And then we have a specific application.bicep that runs my application. Okay, looks good. But then if we go back to the scenario where we have those 4 applications, you would go, for example, to a situation where, okay, for application 2, I also have a modules folder. And in that module folder, I have a function.bicep. And basically for every application we just copy over the files, save it in a Git repository, work again with those files. Maybe for application 4, they make a change, but then the change isn't available for application 1. So making it also very problematic. But then you also may ask yourself, okay, but why do I want to share my Bicep modules? Basically, the one and most obvious thing is not redoing effort. So if you have ever written good infrastructure as code files, it sometimes can take up a lot of time getting everything and every setting correctly configured in your infrastructure as code. So if you would have to redo that for every project or maybe every team in an organization, and I have seen organizations where they have 100 DevOps teams, if each team would have to do that over and over, it would be really problematic as well. Next to that, you would also want to have some discoverability of your existing modules. So it's nice to have Bicep modules, but then they also need to be discoverable within your organization. And of course, reuse and the reuse of code. And another last thing that I really like about the Bicep modules part, and what you could achieve with that as well, is it's here called company approved resources. And I mostly call it certified resources. And why do I call it certified resources? I've seen in very large organizations where they have high standards on security. And basically everyone should have high standards on security. But I think you guys know what I mean, is that, for example, if I would have to deploy a storage account, they have some specific rules that you need to obtain to. So if they would have to check those rules for each storage account going into the Azure portal, they got a shitload of work to do. That's really a lot of work for them to check. Of course, we can configure policies, but you want to make sure that things are handled upfront, not afterwards. So what you could do by using modules, you would be able to create storage account modules, for example, that are certified by the security department and are able to reuse within the organization, making it very easy for all your DevOps teams or for each engineer in there just to pick up that specific certified resource, use it as a module, and then deploy the specific application they are developing or the specific resources they need for something else. But when they are deploying, they know that that specific resource is a certified resource. Okay, but what can we then do with these specific Bicep modules? So for sharing those Bicep modules, of course, saving them in a Git repository is an option. But that does not really makes it very handy to share them between teams, share it between GitHub repositories. So there are some different ways that have been built into Bicep as well. So basically within Bicep, you can use a Bicep registry. And that's just a container registry within the Azure platform. And you can save your modules there. And basically the modules you save there are just saved as a container artifact. And that artifact can be used then in your Bicep code as well. What it gives you is basically specific access control options, like network access. So as you may know, a container registry could be combined into your organizational network, making it not accessible from outside. Then the other option are Azure template specs. So I want to do another round of raising hands. Who knows Azure template specs? Hey, there are not a lot of hands.
Just you and me, is it?
I think so, Matthew. Yeah. Okay. Yeah, I'm not surprised, by the way, but that's also why I've asked, because not a lot of people know this resource and know what it can do. And I don't think it's even, I don't even see it very often within companies as well. But it's a cool, I think it's a cool thing. And as many of you don't know it, I will also show it during the demonstration as well. And basically what it is, it's, as it's specified here, it's a complete unit for deployment. As it said, it's also an Azure resource. And you can have access control per template spec. So for example, a template spec on itself is just one resource. And as you know, within Azure, each resource has role-based access control. And as mentioned below there, at this point, it's ARM. And I'm not sure, but I don't think there is also a Bicep component in there at this point. So it's still ARM. So you really need to think about how you want to handle your deployment methods as well. Specifying and deploying your Azure template specs as well. Yeah, I will show that later on in the demo as well. So how would you then do the reference? So what you see me do during the demonstration is that I have used the module keyword, then with a specific name, and then basically a file path reference. The reference with a Bicep registry or template spec is a little bit different. And you also need to do some configuration in there as well, that I will show in a moment as well. And then you just reference basically to an online location. So as you can see here with the Bicep registry part, it's directly pointed to a registry. This one is directly pointed to a template spec alias, and I will show the alias specification later on, and then to a specific template spec in this example, and then a specific version of that template spec. And it basically counts for the registry itself as well. It's pointed to a specific folder in the registry, and then to a specific resource as well, and then to a specific tag, what's mainly used as a version. What you can imagine then as well is, okay, I have a registry, but how do I then publish my modules to that specific registry? So that's also basically very simple. It's just using the PowerShell module as well. So you have the commandos. So I've lined them up all three for you as well. Just the regular Bicep one, the AZ Bicep one. So that's using the Azure CLI, and also the PowerShell module. It's just basically pointing it to a specific file and then giving it a specific target. And let's make sure that you share your Bicep modules in the registry. One good thing to note here as well is that when using modules, make sure that when you're trying to publish those modules, even if it's your automation, that you have the correct permissions, of course. That's the same for the template specs section as well. As they are Azure resources, you need to make sure that all role-based access control are in place for you to be able to do the specific actions. So for example, for the container registry, these are the ACR pull and the ACR push permissions that you need on those container registries. So let's do another part of the demonstration. So at first, let me just show you guys the template specs. So in my environment, I have a specific resource group where I have some template specs. And basically an Azure template spec is not, it's just an ARM template, but then as an Azure resource. So if I would, let me just pick this one up, the certified storage. It just shows up like an Azure resource. It has a version 0.1, and even I can check all the other versions as well. And it also has a main template, as you may have seen here. And I can click open the main template, and this is basically just shows me the template itself. What you can see here on top as well, this template is created from Bicep. So it's just a generated ARM template from Bicep that deploys a storage account. But the cool thing is that I think that's a cool thing, is that you can use these template specs directly in the Azure portal. So to give you some thoughts about that, but we have some customers that really like to do things themselves. But if I would let them click around in the Azure portal, they would basically go nuts and create everything, set specific things that they should not set. But they really want to have the steer of the car for themselves in their hands. So if they would like to have a new VM, for example, they want to do it themselves and not have to wait to call us and help them. So what we have done for those kind of customers is create template specs in some examples, where they can just go to the Azure portal, click on the template spec, and then click on the deploy button. This gives them just the regular Azure interface. They just need to fill in the information. They need to fill in the name, and then just click on review and create. Meaning that in this example, they would create a storage account. But I'm sure if they would create a storage account with this template, that it complies to all specifications they have. Would I just let them go nuts within the portal? It would be problematic, but this way I'm sure that everything is configured how it should be configured. And I even can build in my naming constraints in my templates, also making sure that everything they create comply with the naming standards of the organization. And I don't have to clean up afterwards when they are done. That's the thing I love about template specs. So to give you the other idea as well, that's basically the container registry, of course. Let me just move to the resource group where it contains, it should be there. So as you can see here, I have a container registry. And in this container registry, I have some repositories. And these repositories are just my modules. So these are basically the modules I can use. I can click this open. I can see the digest. I can see the specific versions of these modules. I can even go further. The only less usable thing about this is that I'm not able to read the specific template in the portal at this moment. So this is basically by just publishing my specific modules. So like you've seen before, it's just a very simple commando that you could run within Bicep. Just going to a publish AZ Bicep module, pointing it to a specific file, and then targeting it to a specific place within the registry. Okay, that's cool. So we have some files in the registry. We know how to do it. We also want template specs, but how do we use them then, of course? So let's go to another sample of where we use a Bicep registry. So what you see here is just an example of, for example, an application. And as you can see here, on line 14, I have, let me get this one out of the way. Yeah, I have a specific module template spec that points to a br/my registry storage account 001. And if you look a few lines down on line 23, we have a module pointing to BR and then the complete registry name and then a module account 00.1. It's the completely the same module, but it's just another way of pointing towards that specific module. And what you see here as well is that you could use aliases to your specific Bicep registry to get the files. A cool thing about the thing as well is that when using modules in a specific registry, it still has IntelliSense. So you don't only have the IntelliSense when you're using modules locally. No, even when you use the online registries, you have IntelliSense that help you along the way of filling in your module requirements. And even writing out a new module will help you along the way. So what you can see here as well is it finds my specific alias. So I could use my alias. The only thing is, after that, you don't have IntelliSense. So you need to make your modules discoverable within your organizations for people to fill in the last part. And we will dive into that later on, of course. So that's one point to remember. Let me just set this one back to the original. And then I also have some examples for the template spec. So as you can see here, it starts with TS instead of BR. It points to an alias called specs, and then to a specific Azure spec. Same for this one, no IntelliSense in the naming of the specs. In the naming, in the parameters itself, you have IntelliSense, but not up front. And how you configure these registries and template specs is by specifying module aliases within your bicep.config file. For the ones not familiar with Bicep, Bicep has a bicep.config file that helps you in doing configurations for Bicep. So in here you specify the registry, even a specific path. You could also include that part, of course, in pointing to the registry, to the module, but it's more easy to do it directly here, and you give it a specific alias. So in this example, it's the alias my registry. So this all sounds good, but how do I really then make sure that modules that I write are shared within the organization, are deployed to a specific location, AKS, for example, a container registry, but also how do I make them discoverable, for example. This is where basically Azure DevOps or GitHub Actions come in handy. And that's, of course, also visible during a small demonstration. So let's first look at Azure DevOps. So what you could do within Azure DevOps is create a part for building your Bicep files, basically building your Bicep modules in this example. So for example, I have here a pipeline called build Bicep modules. And what this does, it does not only build, basically, it lints the Bicep files. So basically Bicep linting is checking if my architecture, my infrastructure as code complies to specific standards. And what you can see here as well It lints all specific templates and then publish them to an artifact. But the cool thing about this pipeline is that it also has a documentation generation step. What this step does, it generates documentation about my module, making it very easy for us to make, for example, a module discoverable within an organization. And basically what it does, it just generates markdown files specified on information that's in that specific module. And in this example, I also have the deploy component. And basically what this does, it releases the modules. So basically it contains scripts to get all the modules from my repository and then deploys them just by using a simple PowerShell script that checks the version for my specific module in the container registry, and then also checks if there's a newer version available, and otherwise just not sub the version, one specific version. But it also does a deployment of my documentation. So when I constructed a new module, it's automatically deployed. It's automatically checked against rules. It's then automatically deployed to my container registry, and automatically my documentation about my modules are automatically pushed to a specific location. So what this example does, for example, it deploys the markdown files just directly into my Bicep in my Azure DevOps wiki. So for example, as you can see here, these are exactly the same names of my Bicep modules, and I can click them open. I can see here, okay, so a specific naming, some description, what's the specific version, basically the latest version in this example. What are the parameters, even specific description of the parameters, are they required or optional, even specific allowed values. It shows me the resources that are in that specific module. So you can see here is that I have in this module, it only contains an application inside, and that the name is constructed, specified on a specific naming convention. And I also get some output parameters. So this way you make it very discoverable for your end users and people that want to use your modules to get it combined. And even if we look into GitHub, for example, do I still have it open? I think so. Let's make it small. Yeah, there it is. I've showed you one example, of course, now in Azure DevOps, but of course, GitHub Actions can do it as well. And in GitHub Actions, there is also a bisync linting action available. Basically, there are two. One created by me, and I think that's the most exclusive one. Not to brag, but and basically what it does, it lints, just like I showed you, all your Bicep files and prints out basically specific naming. But what it also does underneath is it constructs a specific serif file. Normally, when you use the default Bicep linting, it constructs separate files for each scan. This action combines all those results into one, so that you can also use the security components of GitHub to check your specific problems that you have with your infrastructure as code. And that really helps in the complete process of creating an application and moving it into production and making sure that every security aspect is in place and accounted to as well. Maybe now, when you have seen this all, you may think, okay, but if this is all already possible, doesn't Microsoft has something laying around that we can use? And of course, here the answer is yes. So Microsoft has something called the Azure Verified Modules. And basically what the Azure Verified Modules is just, you can you can see it as a container registry in the cloud, where everyone has access to use modules, not to push them, because it's completely maintained and developed and supported by Microsoft. So it's also not a community thing. Of course, you can send in your issues, your suggestions, and everything else, but each module itself needs to be maintained by someone from Microsoft. That's very good to be aware of. And what you see there is that they have specific pattern modules for using in the landing zone concepts, for example, but also just specific modules for resources. And those modules are very good. They are very comprehensive as well. There is a lot of in there as well. You can already know if you deploy, for example, a resource that's coming from the Azure Verified modules, that it complies to some specific security standards. It's all based on a well-architected framework as well. So it's very easy to get started as well. And even what you could do is create your own modules on top of the AVM modules to, for example, be sure that your naming convention is incorporated into a module. Because one thing I see customers having problems with is that they say, okay, I want to have a naming convention, but when we deploy Azure resources, Luke is using this naming convention, Andy is using that naming convention, and Lizzie isn't using any naming convention, she just does something. And by using modules, you can just make sure that there's a specific naming convention already complied into your module, so that the end users of that module only have to use a descriptive name for the specific resource, making it very handy. Also, a short demonstration on AVM, and that's not really much of a demonstration, but if we look at, for example, how to use AVM, then that's very easy as well. So I already have a Bicep file open, and this is basically a small example of just getting started with a storage account for AVM. One cool thing to notice here as well, AVM2, is that of course you have IntelliSense. So we picked the public one in this example, but the cool thing here is that for AVM you have some IntelliSense for resources. So you can see here is that we have a complete list of resources already that are in AVM, and there are a lot of pattern things in here as well. So you can really easily get started with this as well. And if you want to have more information on AVM, you would just need to go to aka.ms/avm, and there you can see a lot of these modules as well. So they have the specific sections of resource modules, also with the specific owners in there as well, and also the specific pattern modules. So for example, for the Azure landing zones and the FinOps toolkit, for example, there are some specific patterns in there already that you can use and just pick up and deploy. And they are also there for Terraform as well. So basically my last slide. So if you want to get started and do not have any insights already on Bicep, be sure to look at the Bicep repository within GitHub. That's github.com/r/bicep. Of course, there's also a lot of information on Microsoft Learn. If you want to look at the demonstration I just give today, or also have a look at the DevOps pipelines or GitHub Actions, they're also in that repository. So you can even pick up the code for constructing the documentation there as well. So that's in that repository, and also the link to the Azure Verified modules. Then only rests me to thank you for being here. if you want to get in contact, these are my contact details. And if there are any questions, I still have some time, I guess. Not sure if there are any.
No, fantastic stuff. No, absolutely. I've just been keeping an eye on the chat, but I think it's just been a little bit of a back and forth. I didn't pick up any specific questions, but if anybody
No, there's
does
been
have
some good
any,
debate,
yeah, absolutely.
good discussion on.
Let me guess, it's about Terraform versus Bicep debate.
Always.
Always, yeah, it's always the same thing.
It's not. No, it's not. Bicep is so much better than Terraform.
Well, I also like a part of Terraform because the other providers you could use within Terraform. That's just something that I really find amazing, and that's also a thing that I find a little bit lacking about Bicep, because Bicep also has some extensions like Graph, for example. But the main thing what happens when you use those extensions is that it's still constructed to a specific JSON-specific language. Let's call it ARM, and then it's sent to the ARM engine. And the ARM engine decides if it moves to the graph or that it moves to the Azure-specific resources. Meaning that as a community, you are not able to contribute as at the whole to, for example, build an extension for GitHub. And that is what you can do with Terraform. And that's one of the things I really find amazing about Terraform.
I think
A couple of
part of that,
questions.
though,
I mean,
is
Alan, you've
because-
asked if the slides are available. Mike, I don't know
Yeah.
if you can make them
I
available
can make
somewhere.
slides available. They are not available yet, but I can make them available.
No, perfect. Yeah, we'll get the links out. And Daniel's asking about AI agents with Bicep. Do you know if there's any kind of integration with doing anything with training agents or configuring agents or deploying agents via Bicep yet?
I don't
John,
think
you
so.
can deploy well, actually, that's,
The
it depends
resource
what you mean
itself.
by agents. But you can deploy. There's a I can't remember its name. I'll see if I can look it up. But there is a whole Bicep landing zone accelerator to deploy the whole reference AI infrastructure piece. So you could cherry pick bits out there. But
Correct.
outside of that, in terms of agents and training them, I'm not sure that's.
No, basically, when we're moving into the resource itself, I don't think there's anything available. Basically, the complete era of resources you need to get started, there is. And I think that's also in the AVM. But really, when looking into training and everything else, I don't think there is. And I don't think it will come as well, because it's really specific.
Yeah, no, got you. No, thanks for the questions, everybody. Really appreciate that. Look, Mike, I know we're running slightly over now, so I guess if there's any questions, you're open for people to contact you and give you a nudge on socials. And of course, any questions, we can forward them over if you do have them. But for now, thank you very much. Really good engagement, really good session. Thank you for coming along and giving us your time. Much appreciated. If everybody wants to show their appreciation, that would be grateful. Thank you, Mike.
No problem.
Okie dokie. Let's move into our next section, which, for those of you that want to join in, is our ever so famous Quiz Quiz. Mr. Fatunker, I'll hand over to you, sir.
Let me just share up the right screen. If anyone is interested, there is a thing out there called the Azure OpenAI Landing Zone, which is one of the accelerators that's around, and that's got a whole load of Bicep.
That's the name I was trying to think of, Matthew.
Yeah.
It basically supports it reflects the reference architecture for AI stuff. So
yeah, that's the one. The other one that's worth of note now is the actual Azure Landing Zone itself.
Oh,
The
they're
ALZ,
brilliant.
the ALZ module.
Oh, if you're not looked at that or using it or thinking about using it, it is amazing.
Yeah, and interestingly, that's moved to fairly recently to AVM. So a load of the components in that are now based off the back of Azure Verified modules, which has been which has been a
Well,
real.
they had the modules, Matthew, originally in the previous format, Carmel, or whatever you want to call it, and they've been jiggling them around, and they put some in, took some out, put some in, but
Yeah.
There will be, I think, soonish, full GA announcement around the LZ stuff for Bicep, but I'm not sure
Yes.
exactly when.
Yes,
Because,
it may be soon. Well, we were speaking to the guys the other day, so.
All right. But Jack's on paternity leave, so that's not exactly helping.
No. There's also been a few changes around those teams as well, so be interested to see what the knock-on effect of that is. So, but we shall see. So we've got 10 questions. They are a mix between some Entra ID things. There's some Bicep questions.
It's not letting me join for some reason.
You always have a problem, Alan.
Not normally, not the last few times. Again, 3178. Didn't like my username.
Feel free to join if you want to join. Absolutely fine.
I think it's because I put ARM in and it didn't like it as a username. How's that funny?
ARM?
Yeah.
I don't think there's not much in the way of validation on there, to be honest. I think I've got a story on the backlog that says I should probably have some validation on them.
You know, he tried a SQL injection. You know he did.
Yeah.
I don't know SQL.
And he wouldn't have been the first person to have tried it, to be honest, either. I
think we're probably, there might be one or two
out there.
folks. What are we doing tonight, Matt? Quiz prizes. Got a few on. Yeah. First place.
First place, yeah.
£25 Amazon voucher for the first place. So quickest fingers make the most points, right?
Yep, that's right. Let's rock.
Let's go.
Okay, 3, 2, 1. What ensures security in Azure Multi Tenant Architectures? Now, this is around the Entra ID piece rather than the. Role-based access. Everyone got that one? Which Azure service helps manage tenant identities? Oh, a long time out on that one. Entra ID. Which authentication protocol is commonly used by Entra ID for secure access to cloud applications? Bit of an obscure one, this one. I think this was a GPT generated one. I've gotten better at the prompts I need to write to generate these things now. So they were getting very wordy at one point. Oh, what Entra ID license do I need to use privileged identity information management? Information or identity? Might be identity management.
Privileged identity management, yeah.
I think it is, yeah.
It is identity, yeah.
It's a P2 license. It's one of the expensive ones.
Oh, that's a bit naughty because it's not.
Well, you can get it on one of like the government or the community ones as well, I think. What's the name of Microsoft's new quantum chip? Which is a fascinating. If you're ever going to want to get lost down a rabbit hole, then read up on that quantum announcement because it's mind blowing. Which M365 application was announced to be going out of support in October 2026?
Ooh.
And I will say 2 of those are already dead.
Yes.
It's publisher.
Oh, I got it wrong.
Ooh, slap on the wrist. Which one did you pick, John?
I picked Infopath. I thought publisher was already gone.
No, Infopath went a couple of years ago. I think, yeah, publisher's
Okay.
just been announced. And another one, sadly, Skype had its original headquarters in which country?
I'd really know this, shouldn't I?
Say goodbye to Skype in a month or 2.
Yeah.
It was Luxembourg. Lots of people knew that. Oh, good guess. Which CLI command lets me deploy Bicep resources to a resource group? Now, I think technically 2 of these are right, but if you try and run one of them, it says use the other one. Oh, only one person got that. AZ deployment group create. I think if you do AZ group deployment create, it complains. It'll work, but it'll complain. Which feature lets me manage resources deployed using Bicep, including deleting? Now, this wasn't mentioned today, but this is relatively new and is a fascinating new resource type in Bicep. Deployment stacks. So this kind of gets around the whole Terraform. The one thing that Terraform does really well is because it manages your state. When you want to delete everything, you just do a Terraform destroy. Deployment stacks gives you an equivalent for that for Bicep. What's the name for the standardized Bicep modules published to public registries? Mentioned a lot.
Should be so bummed if I left early. It was totally
Alan setting up the drum kit, is he?
Of course, it's Azure verified modules. And our winner tonight is Simon.
Congratulations, sir. Simon, I think I've got your email, but as always, do me a favor. Ping me on one of the social platforms with your email, and it'll act as my little prompt so I can get that over to you. Get that sorted for you. So yeah, congratulations. I'm assuming that was you, Alan, in second place there as co-pilot. You love your...
No, I think he was Al.
Oh, was it?
No,
Al?
it's not me. I made
Who's
had a
co-pilot
complete
then?
meh.
It
I
is
put the
Sorry,
window
it was me.
behind my window.
It's
Oh,
me.
well done.
Good. Nice try.
I'm clicking on the team screen going, duh.
No, but congratulations, Simon. Ping me in the chat or just give me that little nudge so I can get it sorted for you in the morning. And on that note, let me just quickly reshare the deck. We shall bring this session to a close. There we go. I think we've got it coming through. Pick the right slide. There we go. So look, thank you, everybody. As always, really appreciate everybody coming on and saying hello, joining in and being part of the community. Really do appreciate that. Thank you, everybody, for giving it the time. And obviously, thank you to Turja and Mike for, giving up their time and coming on and helping us learn something new of an evening. So look, really appreciate it. As always, community use group, it's meant for people like you guys. So thank you, everybody, for turning up. Please do contact us if there's anything you'd like to discuss or add. But for now, thank you, everybody, for attending. Please do help us grow and share where you can across the social platforms. And finally, save the date for the next user group session, which will be on the 16th of April. But for now, thank you, everybody, and we will hopefully see you all next month. Thanks all.
Thank you.
Bye.
Bye.
Take care.